Hello, calculus class. We're going to be working on this FRQ question from the 2014 administration of the exam. We're talking about this differential equation. Consider the differential equation dy dx equals 3 minus y quantity times cosine x. Let y equal f of x be the particular solution with the initial condition of f of 0 equals 1. The function f is defined for all real numbers. The portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So this is the point 0, 1, and I'm just going to try to follow the curves. Maybe it's steeper, maybe it's not, but it does something like this. It's probably steeper over here. You know, it's a general gist. It doesn't have to be perfect. In fact, it's kind of better if it's not. Okay. So there you go. That's that. That one's easy. Let's see what we have to do next, because that was really nice, but there's probably more to do. Part B and Part C. Part B says write an equation for the tangent line to the solution curve in Part A at the point 1, 0. Use the equation to find the approximation. Okay. So I need to write a point 1, 0. There's that point. Notice that's the same point right there. I need to find my slope, so dy dx at 0, 1 is equal to 3 minus the y coordinate times cosine of 0. 3 minus 1 is 2. Cosine of 0 is 1. So my slope is 2. So my equation of my tangent line will be y equals 2 parentheses x minus the x coordinate plus the y coordinate. Then I'm going to go ahead and approximate at f of 0.2. So f of 0.2 is approximately equal to 2 times 0.2 minus 0 will be 0.2 plus 1. So that's equal to, and I'm stopping. That's good enough. I'm going to go ahead and keep going, but that's good enough. 0.4 plus 1, or 1.4. Okay, so you can stop there. You do not need to go all the way to 1.4 at all. I go to 1.4 so I can see if it's right when I look at the solution guide. Find f of y, the particular solution of the differential equation with the initial condition. So now it's time to separate, and to isolate, to separate, integrate, find C, isolate, and select if necessary. So we're there. Okay. So I'm going to start by separating my variables. I have dy over 3 minus y equals cosine x dx. I'm going to integrate both sides. This side becomes the natural log of 3 minus y times the divided by the derivative inside, which is -1. So let's put the negative sign out front, which is equal to the antiderivative of cosine is sine x plus c. And that's it for separate. So we've separated and integrated. So let's see what's going on. Now we're going to find C. So I'm going to plug in the initial condition I was given, which was at 1, 0. So when I plug in 1, I get out 0. Oh wait, when I plug in 0, I get out 1, excuse me. 0, 1, I said it wrong. Sine of 0 plus some c. So this is negative ln 2. And sine of 0 is 0, so that's just c. So c is the negative ln natural log of 2. So my equation is now clean it up. Negative absolute value 3 minus y ln 3 minus y equals sine x move that down. Oh, I'm moving the wrong thing, so there it is. Rectangle. Minus ln2. I'm going to times everything by negative to get that minus sign gone. Negative ln3 minus y equals ln2 minus sine. Make both sides the power exponents of e. So I have 3 minus y in the absolute value still equals e ln2 minus sine x. And so this becomes, the natural log of 2 is just, e to the ln2 is just 2, but it's minus, so it's going to be e ln2, minus means divide, e just go times give me a minute. Okay, so let's double check my brain. E negative sine x, 3 minus y. And so this becomes 3 minus y, absolute value, equals 2 e negative sine x, because e to the ln2 is just 2. All right, now we got to get absolute values to go away. So 3 minus y equals plus or minus mess. And so then we're going to subtract 3, negative y equals negative 3 plus minus 2e negative sine x. Y equals 3 minus plus, and again, not important, but I'm changing all the signs, 2e negative sine x. So now we're going to check our, and select. So going back up the screen, I've got that initial condition of f of 0 is 1. So I'm going to go ahead and plug in. So I know, let's color. F of 0 is 1. So 1 equals 3 plus minus 2e negative sine 0. So 1 equals 3 plus or minus 2. E to the sine of 0 is 0, so that's e to the 0, which is just 1. So I know that this is 1. And so I've got 1 equals 3 plus 2. No, 3 minus 2. Yes. So it is, and when I select, it's going to be 3 minus 2. That's going to give me the right answer. And so it needs to be minus. And so my answer is y equals 3 minus 2e negative sine x. Ta-da. All right, let's talk. Well, how did we do? All right, looks like I'm going to have to scroll, which is fine. taking a look at the answer key. I didn't go quite deep enough over here, but there, I'd be good. I went through the right point. I can see it's deep, slouchy, whatever. I'd be fine. Notice that's only worth 1. Tangent line equation, y equals 2x plus 1. If we go back to my equation, I have y equals 2x minus 0 plus 1, same thing. Okay, so that's worth 1, getting that right. Then my approximation was 1.4. Going back to the answer key, approximation 1.4. And again, you can stop anywhere. It's all good. Then we've got, so for my first 2 parts, I've got 3 points. And then this last part is worth 6. So separate, check. Integrate, both antiderivatives, check. Find your value of C, check. Constant of integration, and then use the initial condition, both of those. Solve for y. Notice solve for y, 1 point. So if you're having trouble solving for y, it's not worth the effort. Okay? But if you can nail these, this is a nice 9-pointer that's fairly easy. At least 6 points I think is easy to get if you get comfortable with the process. And that's that. Let's go back and take a look at how we did. We separated. We've got, for separation, 1 point, antiderivatives, 1 point each, blah, 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 math, 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 all that work to get y alone. Again, it's worth 1 point. Sometimes it's just not worth figuring it out. Okay, selecting all of it from starting with, after I know C, from this point on, that's only worth 1 point. Just something to consider. Okay. All right. And that's that. I will talk to you guys soon. Have a great day.